Greetings to you. Welcome to Physics with Ben. Don't forget to like my videos, subscribe, and share to those that need it. Also, click on the description box below this video and you will see the theory on this experiment. You also see the practicals. I have come in today's video to plot the graph and teach you how to plot graph accurately. Click on the notification bell so that you can also get all notifications when I publish a new content. So let's begin. In the other video, I ran the experiment verification of the principle of movement. The principle of movement states that for a body to be in the state of equilibrium, the clockwise moment must be equal to the anti-clockwise moment. The clockwise moment must be equal to the anti-clockwise moment. Moment simply means force times distance. In this case, your Q is the mass. The moment on this side is this Q times X. And the moment on this side is what? This M times this Y. So that is the moment. Once this condition is met, is reached, the body will have no option but to be in a state of equilibrium. Now, these are the... in this experiment also, in the meter rule experiment, there are two things that are very, very possible in this experiment. To find the mass of the unknown, to find the mass of the ruler. If the mass of the unknown is to be found, this is what you expect. One will be labeled Q and the other side will be varying the masses on the other side. There are moments they will ask you to find the mass of the ruler in the experiment. If the mass of the ruler is going to be determined in the experiment, what they do is that the ruler, the meter rule will not be placed at the knife edge. Will not be placed at the center of gravity, but somewhere, something like this. Yes, so that you put a mass on this side, and then the weight of the ruler, which is all at the center of the ruler, will be the force that will be balancing it on the other side. And sometimes what happens is that you also have to add another weight on the other side. That is, if the weight on the left hand side is greater than the weight of the ruler. For the sake of clarity, I will run another experiment on this next time to find the mass of the ruler. But in this experiment, it is to find the mass of the unknown. So, let us begin. Kindly look at this table of values. We are to plot a graph of, let's go to this quickly. We are to plot, they ask us to, we have done all this. We have done all this and this is where we are right now. Plot, this is where we are right now. Plot a graph of M against Y inverse. Determine the slope S of the graph. Evaluate S all over X. State two precautions. Just screenshot quickly. Good. So we are here right now. So let's plot the graph. In plotting the graph, the first things first we need to do is to find the scale of the graph. Is to determine the scale of the graph. So let us choose the scale for this graph. The graph of M against Y inverse. Take note, observe the trend. This is increase, 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 increase. So increase, increase is the trend for this experiment. And I told you in the other experiment that When you have an increase trend, you are going to have a straight line graph of this nature. When you have an increase trend, you are going to have a straight line graph 0, 0, y against x, for y is equals to mx. Y is equals to mx plus c. When you have an increase trend, you have this graph, or this graph, or this graph. These are the three possible graphs you're going to have when you have an increase trend. One, when it passes through the origin, you go with this equation. For y is equal to ms plus c, you go with this one or this one. So this is graph 1, graph 2, and then graph 3. For our experiments, we will see if it is graph 1, graph 2, or graph 3. We'll check that later. Stay put with me. Don't go far away from here. So let us find the scale of the graph. So we write on the y, which is also m-axis. Good. We're going to choose, this is the WAEC graph I'm talking about. From here to here, from this point to this point is 2 cm. There are 10 small boxes in each 2 cm. Good. Now, we are going to see, we're going to choose a scale in such a way that our graph will occupy at least 1/3 or 1/4 of this, what you are seeing here. Now, we have the maximum value as 60 and then the minimum as what? 20. We are not going to start with 20. We'll start from a value and then ascend to 20. So let's say 2 cm to 10 units. So let's count. 10, 20, 30, 40, 50, 60. Let's say 2 cm, 4 cm to 10 units. 4 cm to 10 units. 10, 20, 30, 40, 50. It will not go. So we are going to choose 2 cm to 10 units. For this reason, we are going to shift our horizontal line up, something like this, so that our graph will be good. So this is 10, 20, 30, 40, 50, 60. So we draw our straight line here, our horizontal line here. Good. Now, we are going to draw the vertical line this way. Please pay maximum attention to everything I'm doing here. And anytime you are asked to plot any graph in physics, do it exactly the way I am doing it here. Good. You draw an arrow here, and this is what? Your mass in grams. If you don't label your axis correctly, the examiners will mark you down. So this is inverse in cm inverse. Good. Y inverse in cm inverse. Good. Now, physics graph will always start from 0, 0, 0. They always start from the origin, 0, 0. The next thing we want to do is to slot in the values for the mass. So let's write. We said for the m-axis, we say 2 cm is equal to what? 10 units. So let's enter this axis. So this is 10. It means each 2 cm will add 10, 10, 10. Good. So this is 10. This is 20. This is 30. This is 40. This is 50. This is 60. This is 70. This is 80. And this is 90. Lovely. Good. So we are done with the scale on this axis. Or for the horizontal axis, the y inverse. We have 0.01 and the maximum value is 0.09. So we are going to say 2 cm to 0.01 units. So let's count. 0.01 times 1, 2, 3, 4, 5. 0.01 times 5 will it give us this value? Let's check and see. We have 0.01 times 5. So 0.01 will not go. 0.01, let's count. This is 1, 2, 3, 4, 5, 6, 7, 8. 0.01 times 8. It gave us 0.09. Let's try 0.02. 0.02 times 5. Okay, it's like 0.02 will go. So we are going with 0.02. So this is so we write that 2 cm is equal to 0.02 units. It means that each 2 cm will add 0.02. So let's start. So our first cm here is, this is 0.02. 0.02 plus 0.02 gives 0.04. So we have 0.04. We have, the next one is 0.06. The next one is 0.08. 0.08. The next one is it's 1. Yeah. 0.02 times 1, 2, 3, 4, 5 times 5 will give us 0.1. The next one is 0.1. So 0.1 plus 0.02. 0.02 plus 0.02. 0.04. So 0.02 times 6, this is 1, 2, 3, 4, 5. We have 0.12. So 0.02 times 7, we have 0.14. So let's stop here. The next thing is to find the value for each small line. Here you divide 10 by 10. The value for each small line here is 1. The value for each small box here is 1. So 10 by 10 is 1. Is equal to what? 1. Down here, the value for each small box is 0.02 divided by 10. That will give you 0. So we say 0.02 divided by 10. You have 0.002. So the value for each small box here is 0.02. So these are decimal numbers. So for you to get the exact number, divide everything here by 0.002. When you do that, you are going to find the number of boxes that will take to the exact value. So the next thing we're going to do right now is to plot the graph. Good. When m was 20, y was 0.031. How can we find that value? So you write that 0.031 divide by the value for each small box. This value here, divide by 0.002. You're going to have 15.5. Round it up, that is 16. It means you're going to count 16 small boxes here. So this is 10, this is 10, 11, 12, 13, 14, 15, 16. 16. Good. So this 16, so let's try 0.02 times 16 will give you 0.032. What do you see? Yes, 0.032. We're going to ignore the other one. Just go with 0.003. Do you get? Lovely. So we are going to trace this line, and where it touches 20, we stop. So this is where they intersect. This is the point. We are done with this particular point. The next point. So the next value is 30. When m was 30, y inverse was what? Y inverse was 0.045. So how do we get this exact value on the graph? Type 0.045 divided by the value for each small box, which is 0.025, divided by 0.025. Sorry, 0.045 divided by 0.002. That will give us 22. I want to verify this quickly. 0.031 divided by 0.002. Yes, okay. So we have 0.045 divided by 0.002. That is 22. You run it up to what? 23. So it means that 23 small boxes will give us this figure on the horizontal axis. So let's count. This is 10, 20, 23. 1, 2, 3. Good. So this is 23. So you put your ruler straight here, and then the reason why you need to know this is that the examiners are not too in a hurry to mark your graph. They will check all these things. So this is where they intersect. This is it. Then you put a circle. Good. Lovely. The next thing we want to do, the next point we want to plot right now is 0.0. When it was 40, it was 0.064. So 0.064 divided by 0.02. 0.064 divided by 0.002. That will give you 32. It means we are going to count 32 small boxes to get this value. So let's count. Are we good? Let's move. This is 10, 20, 30, 1, 2. This is 32. This is where 32 is. So you put your ruler where 32 is on the line, and then where that line intersects with 40. This is where they intersect. That is the point. Now the next one is 50. When it was 50, it was 0.073. So 0.073 divided by 0.002. That will give you 36.5. So you write 37. So let's count. 10, 20, 30. Let's count. This is 10, 20, 30. Count 7 again. 1, 2, 3, 4, 5, 6, 7. This is 37. So you trace this line until it will meet 50. So this is where this line meets 50. This is 50. This is the point. And then the last point is what? When 60, it was 0.09. So 0.09 1 divided by 0.002. That will give you 45.5, meaning 46. Let's count. This is 10, 20, 30, 40. 46, right? Count. 1, 2, 3, 4, 5, 6. This is 46. So you put your line here straight. Where this line meets with 60, that's the point. So this is 60. So the next thing is to draw your line of best fit. Quick. So I told you the line will be, this is an increase. So this is your line. Watch what I'm doing. You don't use an opaque ruler while plotting your graph. So place this line, this ruler once. So we have touched 1, 2, 3, 4 points. This one is a little bit out, but not that out. So are we good? Yes, let's go. Perfect. A straight line graph passing through the origin and with the equation y is equal to what? mx. Meaning there is no intercept in this. The next thing is to draw your big triangle. We choose this point. We choose which point again? We choose this point. Your triangle should be big, because when you have a big triangle, the error in the experiment will be minimized. The big triangle, that is it. So trace it down, dot, 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 dot. Trace this point down, dot, 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 dot. So this point becomes your y inverse 2, your y inverse 1. Trace this point. This is dot, 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 dot. And this is your M2. Sorry, my camera was shaking. And this is your M1. So what is your slope then? So this is change. Change in M. This is change in what? Y inverse. Can you see that? So this is how your graph must look like. So wonderful, so fantastic. This is lovely. You can screenshot this. Lovely. Now, your slope is change. Change in M divided by change in Y inverse. This is the same thing as M2 minus M1 divided by Y inverse 2 minus Y inverse 1. So this is the same thing as this is 80. This point is 80. So you have your M2 is 80. So 80 minus your M1 is 20. 80 minus 20 divide by your Y inverse 1 is 0.12. That was 0.12 minus this point. Let's count. We have 0.002 times the value for each small box times, let's count. This is your Y. This is 10. 1, 2, 3, 4, 5, 6 times 16. So we have 0.032. So if you do that, you have 60 divided by 0.12 minus 0.032. What do you have? You have 0.088. So your slope 60 divided by 0.00, sorry, 60 divided by 0.088, you're going to have 681.818. So your slope is this. What's the unit? The unit for your slope is gram. Mass is gram. Gram cm. This is the unit for your slope. Gram cm. So we are done with this, and this is perfectly correct. This is it. Good. Now the next thing is that they ask us to evaluate s all over x. Evaluate what? xs all over x. That is the slope all over x. X is simply what was constant throughout the experiment. What is your x? From the graph, your x is this. Is 30 cm. It's constant throughout the experiment. So we write that the slope, this is the same thing as what? 681.818 divided by 30. Mind you, your slope is GCM divided by 80 what? cm. Cm will cancel cm. So what do you have? You have the value of slope divided by what? 30. What do you have? You have 22.72 gram. Approximately you have 22 gram. So this is the value for the unknown mass in the experiment. That is it. The Q is the value for the unknown mass in the experiment. There are two ways of finding Q. You can choose to say that this times this. You can choose one value. Maybe when the mass was 20 times. For instance, you may say 20 times this. 20 times this is equals to Q. 20 times this is equals to what? Q times X. And then you make S the same formula, and then you find the value for. So let's try that quickly. There are two ways of doing that. We have, let's try it quickly. We have, let's choose 30. Okay, let's choose 20. We have 20 times 32.1 is equals to what? Q times 30. You divide both sides by what? 30. What do you have? So you have 20 times 32.1. You have what? 642 divided by 30. If you do that, divide by 30. You do that, you have 21.4 gram approximately. So this is the calculated value, and this is the calculated value, and this is the what? Experimental value. You see that experimental value, calculated value from using equation, moment of force. So the next thing we have to look at, they ask us some very key questions here. They say, state two precautions you took to obtain accurate results. Number one, you are using the mass meter rule. You say, I avoided error due to parallax when taking reading on the meter rule. Number two, I close all the air sources to avoid drag. That is that for that. Three, I explain what is meant by center of gravity. Center of gravity simply means a point where the entire mass or the entire weight of a body is concentrated. For this meter rule, the center of gravity is 50. The next question they ask us to solve is what you are seeing here. I will quickly make a short video on that and add it to this one, but you can use that as a challenge and then look at it. You just screenshot and help me do the rest. So to this end, we have come to the end of this video. I hope you have learned how to plot your graph correctly. Replicate this method in all your graphs and you see yourself getting A's in physics. Don't forget to subscribe and share this video. Thank you. God bless you. Bye-bye.